2017 Canadian Open Mathematics Challenge, Part A. The average of the numbers 2, 5, x, 14, 15 is x. Determine the value of x. You would, of course, add up these numbers to get the average, and you would divide by how many numbers there are, which in this case is 5, and that equals x. So this is the algebra we have to do. So the top becomes 36 plus x, and cross multiply to get 5x. Bring the x to the other side, we get 4x. Divide through by 4. 36 divided by 4 is x, and therefore x is equal to 9. An equilateral triangle has sides of length 4 centimeters. At each vertex, a circle with radius 2 is drawn, as shown in the figure below. The total area of the shaded regions of the 3 circles is a times pi centimeters squared. Determine a. Well, each of these, since this is an equilateral triangle, each of these angles will be 60 degrees, correct? So because it's 60 degrees, that's how we would figure out the area of that pi segment. And there's 3 of them. So there's 3 of those pi segments, right? One's there and the third one is there. This was the first one. And each pi segment, you would take that 60 degrees and divide by 360, because that's the fraction of the total area of the circle. The total area of the circle is pi r squared, where r is the radius. So this would be the area of our shaded region, AS. Okay, let's proceed here. So this looks like 3 over 1 over 6, and then pi r squared, well, r is 2. They gave us that, so 2 squared. And then they told me that this is equal to a times pi, right over here. Okay, the pi's cancel on both sides, so we're just left with a. This is 3 over 6 times 4. So 3 over 6 is what, a half? So 4 over 2, and therefore a is equal to 2. And that's it. Two 1 by 1 squares are removed from a 5 by 5 grid as shown. Determine the total number of squares of various sizes on the grid. Okay, so first let's calculate what kind of sizes we would get. And I think 1 by 1, 2 by 2, 3 by 3, 4 by 4, and of course the largest 5 by 5, because that's the entire grid is 5 by 5. Okay, let's start counting. 1 by 1, well, those are just the individual boxes like this, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23, if I counted properly. So let's put that here, 23. This is the number. 2 by 2, okay, 2 by 2, we got to be careful. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 is what goes there. 3 by 3. 3 by 3, here's 1. 3 by 3. Any more? 2, 3, 4, and I think that's it for 3 by 3. So that's 4. 4 by 4, we can't make any. Yeah, 4 by 4 falls apart because of those have been removed, so we won't be able to do a 4 by 4. And then 5 by 5, obviously we won't be able to do that. So that's how many we have. Add those up, and we get 39. So 39 is the total number of squares of various sizes on this grid. Three positive integers a, b, c satisfy 4 to the power of a times 5 to the power of b times 6 to the power of c, which equals 8 to the power of 8 times 9 to the power of 9 times 10 to the power of 10. Determine the sum a plus b plus c. So the first thing I'm going to do is break these up into their prime factors. So this is going to be 4 to the power of a times 5 to the power of b times 6 to the power of c is 8 to the power of 8 times 9 to the power of 9 times 10 to the power of 10. Okay, so let's break these up into prime. So this will be 2 to the power of 2 to the a. 5 is already prime, so I don't need to do anything there. 6, however, is 2 times 3, to the power of c. 8 is 2 to the power of 3, all to the power of 8. 9 is 3 to the power of 2 to the power of 9. And 10 is 2 times 5, all to the power of 10. Okay, so now let's see what happens. This will be 2 to the power of 2a. This is still going to be 5 to the power of b. This will be 2 to the power of c times 3 to the power of c. On this side, 2 to the power of 24, 3 to the power of 18, 2 to the power of 10, 5 to the power of 10. Okay, now let's combine the 2, and then if we use exponent rules, it'll be 2a plus c. We're combining that with that. 3 to the power of c, 5 to the power of b. And that's all we can do on that side. On this side, we can combine those two to get 2 to the power of 34, 3 to the power of 18, 5 to the power of 10. Okay, now the bases are the same, so the exponents are the same. So this is the same as that. So 2a plus c is 34. That is the same as that. So immediately we get that c is equal to 18. And that is the same as that. So we get b is equal to 10. Now we just need the value of a, so we can use this equation to do that. 2a plus c, but c is 18. So put that in there. So that means 2a is 16, and therefore a is 8. There we go. We got a, b, and c. Now they want a plus b plus c. That's going to be 8 plus 10 plus 18, and that is 36.